All right, we want to look at the test for independence and association, okay? Big difference is homogeneity. You're comparing multiple populations or treatments, okay? Two or more simple random samples or random assignment to two or more treatments, okay? And then you're comparing those different. So like they're both going to have two-way tables, okay? But here you are categorizing two variables within one sample, within one population. So here, if it's homogeneity, then you're going to have a categorical response variable, category over here. But here, this category is either treatments or populations, okay? The different treatments or different populations, okay? But if you're doing independence and association, this is still a category, and this is just another category that you're choosing to compare. So you take one sample of people and you say, do people who prefer cats also prefer odd numbers, okay? Is there an association between what type of pet people prefer and what type of number people prefer, okay? So it's the difference between one population or multiple populations, okay? So the chi-square test of an association, by the way, all the other math exactly the same. You're still getting your degrees of freedom is row minus 1, column minus 1, okay? You're still getting your expected is row times column over n, all right? Everything is still exactly the same, all right? So chi-square test of independence. The null is that there's no association, or the two categorical variables are independent, okay? You can word it either way. I like it. Independent in the null, and then the alternative is an association. Single, simple random sample. So notice a single, simple random sample, okay? And then we classify them of two categorical variables. So there's two categorical variables. Now within one type of pet, it might be dog or cat or bird or fish or other or none, okay? You could have multiple groups within a category and then multiple groups within a category. I like odd, even, or non-integer, right? Like whatever. You could have multiple groupings, but two categorical variables. Pet preference, number preference, okay? But within one SRS. They all come from the same place, all right? So here's an example, okay? They look at firms like, you can think of like McDonald's, okay? Successful or not, based on, did they have a clause in their McDonald's franchise to say, we are the only franchise that's allowed in this territory or not, okay? You can see most of them, when they looked at the sample of all the McDonald's or all the whatevers, okay, most of the franchises were in the yes category, okay, and most of the franchises succeeded, all right? But is there an association between being in the yes category and success, okay? I would imagine that if I have a clause that says you can't have another McDonald's near me, there's less competition, and anyone who wants McDonald's is going to come to my McDonald's, and I'm more likely to survive. Whereas if there's no clause, I'm more likely to have competition, and I'm actually more likely to not survive and have to go out of business, okay? So is the success of a franchise, success, one variable, independent of the other variable? That's how I want to word my null hypothesis, okay? My alternative is the success of a franchise associated with having an exclusive territory? If they're independent, then the percentage of people who are franchises who are successful should be the same regardless of whether or not they have this clause. And if there's an association, then the percents will be different depending on whether or not they have the exclusive clause, okay? So the null, success, and exclusive territory independent, association between success and exclusive territory, okay? The counts are all at least 1, okay? At least 80% of expected, or at least 5. This is my least possible expected. If I do 47 times 28 divided by 70, I can get the number of expected right here. So 28 times 47 divided by 170 This is my expected count in that block, which is 7.7, which is at least 5. So we're in good shape. Okay. Now, if I want to work this out, I want to punch this all into my calculator. Okay. And so if I look here, let's see if I can get this a little bit clearer for us. Whoa. Sorry about that. Okay. So if I go into my matrix, and I edit my 2x2 matrix, and I make it, it's a 2x2, and I want to make it 108, 15. It doesn't actually matter which way, as long as you keep your rows and columns lined up, you're in good shape, because it's just looking for, is there stuff unusual in this? Okay. Then I can go stat tests and do my chi-square test. It will calculate for me. I made my observed, and you just saw me make it. It will create my expected in B, and I can even go look at it later to get my expected values. So my chi-squared value is 5.9. Okay, I've met all conditions. I'm doing a chi-square test of independence, and my p-value is 0.015. So if I picked an alpha of 0.05, we would reject the null that success and this exclusivity clause are independent. There is sufficient evidence to suggest that there is an association between success and the exclusive territory clause. Okay, so that's the flow and the difference between homogeneity and independence. It's about the number of samples that you got your data from. Okay, so good luck and farewell.